The next presentation is called Sounds Aware, a mobile app for raising awareness of environmental sound. That's by Tate Carson from Louisiana State University.
Yes, my name's Tate Carson. I'm from Louisiana State University. You can find all my information on Keybase, so my email and my GitHub, other stuff. And I'm going to be talking about Sounds Aware, a mobile application for raising awareness of environmental sound. So a little bit about how I got started thinking about this app. So it started while I was taking walks around the lakes by my house with my dog. My dog Lucy's my dog here. And so when I first started, I had a lot of anxiety. I was sort of trying to walk to kind of lessen some of this, and so I listened to headphones just because it was too much to walk around without any sound. And as I started doing this, I realized there's a lot of sounds of nature around me, and I wanted to hear them coming through my headphones, but I didn't just want to take out and just listen. So when I tried to do that, I realized there's a lot of nature around, but I'm in this neighborhood that has a lot of cars, a lot of people mowing their lawns. In the States, a lot of people mow their lawns. And there's a lot of construction noise. And so I kind of wanted, and then here's an example of some noise. Oh, no sound, okay. So I wanted sort of the best of both worlds. I wanted to be able to listen to music sometimes, and sometimes just be able to hear the nature that was around me. And so this is what Sounds Aware allows me to do. It's a system that if it hears noise, it plays nothing, and if it hears noise, it plays music, and if it hears nothing, it just doesn't hear. If it doesn't hear any noise, it plays nothing. And so Sounds Aware, just to say exactly what it is, it's a web application that runs on a smartphone and uses machine learning to detect human-made sound, anthrophony, and masks it with ambient music as a user walks around their environment. And so this is a quote by David Dunn that I like to kind of situate a lot of my work in. And to what extent might the technologies of communication, art, and entertainment serve as a prosthesis that would provide us with experience of wilderness that would not only enrich our human identity, but help us to preserve and expand the domain of the non-human world? So, and then further, so the goal of Sounds Aware is to bring a user's attention to the geophonic and biophonic soundscapes, so the sounds of the earth and the sounds of non-human animals, to bring awareness to these sounds that are often masked by noise pollution, that we're often not aware of them in these urban spaces. So Sounds Aware seeks to shift the user's concept of nature to something that is not separate from us. And so important in this work is this idea of noise pollution. So in 2011, the World Health Organization report found that there is overwhelming evidence that exposure to environmental noise has adverse effects on the health of the population. So Sounds Aware shifts the user's attention away from noise pollution and to nature, hopefully, which may help mitigate the adverse health effects caused by noise pollution. While a reduction in environmental noise is at the source would be the best way to solve this problem, masking the noise is a possible stopgap solution. A masking solution has already been implemented by several projects mentioned in the paper, but not yet with a mobile device. So this is what I was attempting to do. And then further, psychologist Stephen Kaplan found that stress reduction can be aided by the experience of the natural environment by providing a restorative environment that reduces fatigue caused by directed attention. Kaplan did not mention sound directly, but a recent study by Eleanor Radcliffe has extended his research to show that certain bird sounds may provide restorative benefits. And so this is sort of situated in the work of R. Murray Schafer and soundscape theory. And so he suggested that we should listen to the environment as a musical composition. And then he categorizes the environments into lo-fi and hi-fi, so urban being lo-fi and rural being hi-fi. So a rural landscape is hi-fi because there's a low noise level, which allows one to hear more clearly. When in lo-fi urban landscapes, we are dealing with a lot of sound masking, getting less discernible urban aural information. So soundsaware brings attention to that noise by masking it with music. So when you hear the music, you know that there's noise going on. Possibly reducing its negative impacts, as described in the WHO report. The music of soundsaware and Schafer's environment as musical composition combine as a duet to create a new and unheard work. So also, it's situated in this idea of ubiquitous listening, that we can always listen to something wherever we are, and that like people in a city or in a sort of urban environment are doing this very commonly. They're creating this sort of private listening experience. And this was first written about, that I've seen, by Ian Chambers, and he was writing about the Walkman as this first sort of private listening experience that people had this ability to create this bubble around themselves. And so this is sort of furthered by CD players, and now mostly with mobile phones. And then further, there's this sort of new art form that we call an audio walk that's described by Joanna Steindorf as experiments and works that combine walking and listening to a mediated soundscape over headphones. That an audio walk takes place using headphones is important because it adds a second layer of private sound to any place and situation, therefore transforming or enhancing the current spatial experience. So some related work. There's a piece called The Quiet Walk from Alessandro Altavia and Atao Tanaka. This is a locative artwork, a locative audio walk artwork for explorations of the urban landscape, where the goal is to find the quietest place in an urban location. The app notifies users if the surrounding sounds are too loud. It also records the GPS locations of the quiet places that are found so that a user can view a sound map of their walk. This might be the project with the closest concept to soundsaware, but there are some key differences. The quiet walk only recognizes loudness levels and does not categorize the sounds. Because of that, a loud anthrophonic sound, human-made sound, is treated the same as the sound that's not human-made, which probably produces false positives. This more intelligent system was proposed in the conclusion, but was probably not tried because of technological limitations. This was done a few years ago. Or maybe there were other reasons. Okay, so the user interaction of soundsaware, which I will demo this later tomorrow, but I'll just describe it now. So headphones are required so that the microphone on the phone does not pick up the music playback, and to create the private listening experience. So when a user first opens up the application, they'll see it start to guess the surrounding sound. So is this a car? Is this a bird? And when assured the microphone is working, the user can then start the music by clicking the play button. The music now responds to the surrounding sounds. The user can adjust the listening sensitivity of the microphone to their liking. So if you're in like New York, you might want it to be less sensitive, or if you're in a place where there's a few cars, you might want it to be more sensitive. So after testing the success of the system and interpreting the environment, the user can now add their own training data. So they start off with a certain training set, and they can add their own data for things that are in their environment. And to do this, they can select a tag, a sound category such as a car, They'll wait for a car to drive by, and they'll click record. And so this hopefully will make the system more accurate for people that are in different environments that are not like my own. And so the tags that are available are on the right, and they're grouped into these different categories, which are sort of defining their origins. So geophony, anthrophony, and biophony. So sounds of the earth, sounds of humans, and sounds of everything else. And I grouped them like this so that I could map them in different ways. And so these are the data points that I recorded. So everyone starts off with this. So it's the most wind, because it's always windy in Louisiana. Footsteps, because I'm always walking around when you're using it. And then birds and rain and cars. So more data could have been added to this, but I think it made it pretty accurate with the amount that was here. Okay. And so what did I use to do this? The most important part of this was the feature extraction library. So I used Meta.js. And I used the MFCC, the mel frequency spectral coefficient audio feature. And the learning algorithm I used to do the machine learning was just simple k nearest neighbor, no TensorFlow or anything. And so the reason that Meta was important is it allowed the feature processing to be done, the feature extraction to be done on the client. And so when you access the device, you just need a server to get the website and the data, and after that, you can walk around. You don't need any other internet connectivity, which I thought was pretty important for this. So I also used Tone and P5.js for the sound visualization. So the composition was influenced by ambient music because I wanted the sounds to be sort of sounds that could flow in and out of the natural soundscape, and I thought that would make sense, something not too jarring. They were also influenced by Aeolian practices, basically like wind going through harps, and the music of Lamont Young. So it uses the Lamont Young's well-tuned piano tuning. So this is the mapping. This is why I organized the sounds into certain categories so that I could deal with the mapping now. So it maps the loudness of the acoustic environment to the amplitude of the ambient composition. So I'm doing some smoothing with the 200 previous loudness values, so they're averaged, and the amplitude ramps to a given value. So I averaged the previous 200 values, and then map them to the amplitude. So it sounds where here's an anthrophonic sound, the amplitude is faded up to negative 3 dB. If it is a geophonic sound, it sort of rides up and down depending on the amplitude that it hears, creating sort of a wind chime effect. Geophonic sounds also affect the modulation index and harmonicity, creating a sort of change in timbre. And then if a biophonic sound is recognized, it fades all the way down so that you can listen to the environment. I did a short evaluation that I'll go through in the next minute. So I'm almost out of time. So I'll just you can read this later. But it was just to see what do people sort of recognize already in their environment, and then after using the app, do they recognize more things? And so for a few conclusions, after I started using this app for myself, I eventually was able to take off the headphones and just walk around. And then later, a few months later, I lost the headphones, so I just didn't use them at all. And now I can walk around and just listen to the sounds and get less annoyed by the mowing of the lawns and everything. And I don't know if that would have happened if I hadn't started working on this. It kind of changed my conception of my environment. So future work, I'd like to working with a microphone on mobile and different browsers is sort of challenging. And so I was thinking that some sort of a native app or progressive web app would be good. And then there's a library called Capacitor, which would allow you to write one code base and sort of target different devices and still use web audio, still use like a web view. That's something I might want to look into. And then something else, user accounts, so like giving the users the ability to save their data long term, that's not possible now. And then a lot of people mentioned wanting to play their own music. So right now it's only my composition, but adding in the ability to let people stream from Spotify or whatever. Or if they do use my own music, they can kind of tune it a little bit to their own liking. So I'm doing a demo of this. If you want to try it, like later, you can. It's up here at Soundscape, or you can come to the demo tomorrow at this time. So I think we have a few minutes for questions.
Yeah, that's brilliant. Thank you very much. We have a question over there.
Thanks. You mentioned tracking footsteps as one of the sounds. I'm curious how you categorize that, whether they were geo, anthro, or biophony.
I categorize them as biophony because I know they're coming from me, but I'm always moving. You're always moving when you're using the application, so I wanted that to be sort of a silence. And so, because if you didn't, then you would never hear anything. You'd have to stay still. Yes?
Thank you. That was very interesting. And actually, perhaps the most interesting thing for me was at the end when you said you lost your headphones and then your ability to listen to the environment changed. And I personally kind of don't use the word noise, and I kind of try to ban it in my students because it's usually used in a derogatory sense. Mm-hmm. And I often think of these sounds that they are fundamentally part of the ecology, and somehow we need to understand them as ecological in order to change that balance.
Yes.
So I was kind of wondering, it seemed at the end that you were pointing to a transformation having taken place in your own listening practice. And I was wondering if that's a surprise to you or whether that's really kind of what you set out to do, was in a way to not need your app after a short period of time.
Yeah, I guess it's sort of funny that I built something that I don't really need anymore. Yeah, I mean, it's to sort of create a shift of how you feel about these sounds. I think if I was in a more noisy environment, I would probably use this more often, like New York or something.
Well, brilliant. I think we should continue. Thank you very much.